Okay, today we're going to go into a little more detail on the scientific revolution. Exactly what that is, we'll get into in just a bit. So, to start off, is the Earth or the Sun the center of the solar system? Pretty easy question. Seems like everyone knows it. The harder question is, how do you know this? Can you prove it to me? Without, anyway, resorting to, well, this science book says it, or I can look on the internet, or a bunch of different people agree with me. How can you prove that the Earth goes around the sun and not the other way around? This is kind of a silly question because, I mean, this is just a given fact nowadays, but it wasn't always. Especially because the obvious answer does seem to be that the sun goes around the Earth. I mean, we can see that with our own two eyes. This is a question at the center of the scientific revolution. These are two kind of models of the solar system that, for a while, both seem pretty valid. First, there was what was called the geocentric model of the solar system, which had the Earth at the center. Geo meaning Earth, centric meaning center, where there was the Earth at the center, and you had the various planets and the sun and everything around it, all the stars circling around the Earth. This is contrasted by the heliocentric model of the solar system. Helio meaning sun, centric meaning center, which had the sun at the center of the solar system and all the planets going around the sun, including the Earth. The problem with this comes from a couple of Bible passages, as we can see here, which do reference that the sun goes around the Earth and not the opposite. That, it doesn't necessarily say it directly, but it does make this reference to it. So for a long time, it was just seen as a given that the sun goes around the Earth, not the other way around. Not only does it just seem like the obvious observation, but there's this religious backing to it. And back then, people took religion much, much, much more seriously than they do now. This was the policy actually enforced by the Catholic Church, which even today is the largest group of Christian churches in the world. Many times it's called, this largest single religious sect. In the 1600s, it was an extremely powerful organization, more powerful than most nations at the time. It's ruled by a single ruler, the Pope, and I mean, it still exists today, but it has changed much since then. These are various popes from history. This is our modern pope, as you can see, um, and definitely like some of the older ones. They have these crazy fancy hats. The popes try to give off this air of majesty, of royalty, of wealth, of power. In the clothing that they do, and that of the clothing that they have. Which brings us to the scientific revolution. A series of events that results in the creation of the scientific method and the advancement of scientific knowledge. This assumption that we have today that, well, yeah, like you should try and look at things, logically, and use science and facts to figure things out, and not just accept what you're told. That's a pretty new idea, and its start is in this scientific revolution and some of its major thinkers. It definitely wasn't a revolution where people were overthrown and killed for the most part, but it was one where our understanding of how we figure things out about the world changed extraordinarily. His two biggest tenets were empiricism and rationality. Now, empiricism is experimentation. This concept that, well, if you want to prove something, you got to test it. You got to be able to get some facts on paper showing that what you believe is true. The other being rationality, that things need to logically stick together. This is in direct opposition to kind of this faith based idea that, just because the Bible says something doesn't necessarily mean it's true, was one of the tenets of this rationality. Things have to make sense as well, they can't just be assumed. One of the first thinkers of the scientific revolution was Nicholas Copernicus. He was the creator of the model of the solar system with the sun at the center, this heliocentric model. Now, his ideas were in direct confrontation with the Catholic Church. And he knew this. He knew that it wouldn't end well if he started spreading and talking about his ideas um, in view of the church. So he published this heliocentric model idea very shortly before his death. And by then, I mean, the church couldn't do anything to him. This led to the Council of Trent, a meeting of Catholic leaders to combat what was at the time called the Reformation. As I'm sure many of you know, You might consider yourself Christian, but you probably aren't Catholic. The Reformation was sort of the start of what was called the Protestant Reformation, where a lot of or a lot of Christians began breaking away from the Catholic Church. And the Council of Trent kind of had a really hard stance on it, that anybody who disagreed with the church would be a heretic, and it set up what was called the Inquisition to punish these heretics. That brings us to Giordano Bruno. This was, I guess you could call him a scientist in kind of a way. He was more of a philosopher. He just kind of hypothesized, and he wrote a lot of books and like stuff. Kind of, he didn't know this stuff for sure, but he's just wondering. He's just saying it, and publicly talked about what if the stars in the sky, they weren't just these tiny points of light, they were like other suns, and maybe those stars have their own planets, and there might be alien life on these planets. He was also a weird advocate of like pagan beliefs, of like nature worship and stuff. Um, both of these ideas stood in direct combat to the church. The Catholic Church, believed that it was humans were the only real valuable life in the universe. Other stars, other things, not only weren't they, they were not like us. They're just these points of life, and they didn't have life on them. Earth was special. Earth was God's creation, and it was blasphemy to even consider or wonder about this fact. Bruno refused to recant his beliefs. He refused to take them back, and for that, he was killed or executed by the Inquisition. He was burned at the stake. You're welcome to read this very long passage, but it kind of in more detail explains how he just wondered, not even saying this is true, but just wondering, there's got to be some other life out there. For how much stuff it is and how much evidence there is, there's got to be something more out there. And how are they more, or how are they might, there's certainly these life forms on these planets can't be any less valuable than we are. They must be just as magnificent as our own. Then we come to Galileo Galilei. He was the man who more or less invented the telescope as we know it today. Moreover, he was the first to take this telescope, and instead of looking at things far away on Earth, he pointed at the sky to look at planets and the moon. And he discovered, the craters on the moon. He discovered the moons of Jupiter, and actually was the first to see a lot of these planets up close. He was warned by the church not to publish his ideas, but he did so anyway. So there's this idea of, was Galileo a heretic? The church definitely thought so. They found him guilty of vehemently suspect of heresy. All of his works at the time were banned. All of his books banned, all of his ideas banned. They still got out. That's how we know about him today, of course. And he was put under house arrest for the rest of his life. He was basically judged by the church, and of course, the church found him guilty. Despite this, Galileo and the other scientists of the scientific revolution kind of had this spark effect. They were the first to think and dare to challenge authority in this way. And their spark would eventually light a very, very large, much larger fire in the Enlightenment, which we will get to soon.